We can tell the past of human history by finding how much energy we have used. It started off with humans using their strong muscles, after which we learned how to control fire. And as any curious species, we didn't stop there. We industrialized the planet using mines and fossil fuels, after which we reached today, known as the atomic age, where we learned how to split the nucleus. And right now we are having a transition into sustainable energy, and maybe even fusion energy, if we're lucky enough. But that's an idea for another video. And if we're not destroyed by our own kind, we can easily take over our planet peacefully and for the better. And once we've reached that point, we'll start looking beyond the Earth. But you see, Earth does not have enough energy. Our sun produces 100 quintillion times more energy than the most sufficient nuclear reactor on Earth. So if we need to turn into an interstellar species, we need a Dyson sphere. And here's how we get there. If we build a Dyson sphere, it would be the largest man-made creation ever. This would be the greatest leap for humanity in history. We would turn into the first interstellar species known today. Let's talk about the design. So, how do we expect this to look? Well, a large shell around the sun would not be the way to go. First of all, we do not have enough material to cover the whole sun. It's huge. And secondly, we do not have enough energy to get all this together. It's like you would need a Dyson sphere to make a Dyson sphere. And let me tell you what I mean. If we were to use all the fossil fuel and uranium on Earth, we would only be able to launch something as heavy as the Mount Everest. And yeah, lastly, we would freeze to death with no heat from the sun approaching to us. Something that might work is a Dyson swarm. This is basically satellites that redirect sun's energy to a certain point. And this can produce humanity with almost unlimited amounts of energy. So the idea is divided into three main parts: material, design, and energy. First, we need to find the perfect planet that has raw materials needed to build the satellites and is easy to disassemble. Out of all the 9 planets, sorry Pluto, out of all the 8 planets, Mercury seems the best one, since it has no atmosphere and it has 1/3 of Earth's gravity. But before we get there, I have to tell you something, and it's quite important. The Kardashev scale. This is a measurement to see the energy usage of a civilization. And here's how we measure it. Kardashev 1, a civilization that harvests the energy incident emitted by its closest star. Kardashev 2, a civilization that harvests all the energy emitted by its closest star. And Kardashev 3, a civilization that harvests all the energy from its galaxy. Currently, we are at not even Kardashev 1. But you see, if we build a Dyson swarm, we would automatically reach Kardashev 2, and in no time, Kardashev 3. And another important thing, if we continue using the same amount of oil that we have been using right now, we would run out of oil in the next 150 years. So we have to act fast. Okay, back to the Dyson swarm. You see, humans are very difficult and expensive and sensitive to keep alive. That means we'll have to automate as much as possible on Mercury. The four major pieces of technology are solar collectors, miners, refiners, and launch equipment. So the solar collectors will help produce energy needed to disassemble the planet. We would either send them to like a traditional solar panel or mirrors that help us to mine soil of Mercury. The soil will be refined in order to get all the useful materials needed to make the Dyson swarm. But after doing all this, we have to find out a way to get these satellites in the sun's orbit. And if you thought rocket, no. Because you see, rockets are too slow and are too expensive. And that's not what we want. Instead, we would use something as an electromagnetic railgun, which launches our satellites at high speeds, and it's fast. It can launch many at once. Not at once, but in a short period of time. And our satellites will be packed tight as efficiently as possible. And once gone in the sun's orbit, it would unfold like a piece of origami. By doing this, we can use the energy produced by the swarm existing to make even more bases on Mercury and speed up the process faster and faster. If a square kilometer of these satellites takes 1 month, we would be done in a decade. And let me make one thing clear. All what I've just yeeted at you, all the information, is not only crazy, but according to physics, it's possible. And in a few decades, we might have to even shift to a Dyson sphere. Building a Dyson swarm can enable us to do things like floating cities, terraforming planets, and living in different galaxies. And here on Earth, we can produce every single place with almost unlimited amounts of energy. And we can do more as well. Once we build a Dyson sphere, the only restrictions we have is our own imagination. Okay, you reached this far. I would really love it if you could subscribe, comment, and like the video. Okay, bye.